Okay, testing, testing. 1, 2, 3. Great. Just a second. Everything looks good. Okay, let me just close this. All right, good. So, on the last stream, we got this expression here, 40 plus 2 divided by 1 or something similar, and we turned it into an intermediate representation, which looks kind of like assembly, which we can then output to assembly, but we didn't actually output it to assembly and test it. So I want to do that at the beginning of this stream. And then we're going to move on to stack allocation because, you know, if we have too many of these sub-expressions and they require too many registers, we're going to run out after 7, but I think we're going to run out after 6 because, well, we need to put something into a register to push it to the stack, I believe. I think the syntax is like push RAX or whatever. So you've got to have the value in RAX to push it to the stack. You might actually, there might be a move where you can do like move RSP some immediate value. I don't know. But anyway, we'll just, we'll use the push and pop, I think. No, we don't want to move into the RSP. It would be move address that's stored in RSP, like this, right? That's the stack pointer. Yeah, I think that's right. Not sure if that works. Probably does. But we're going to use the push and pop. So first we'll get this intermediate representation. Here we've got 40 plus 2 divided by 1. And we'll try to make this actually run. The problem is that the assembly it's going to output is not going to... Well, we could just make it output whatever assembly we want. So why don't we do that? So in our emit program, it was taking a node before, but now it's going to take... I'm just going to rename this to old or something. Now it's going to take the list of instructions here. And this should be pretty straightforward. I guess we'll return a string as well. We'll do the string builder thing. Actually, I'll just copy this code here. So we'll get the setup code, hard-coded entry point, etc. Pass in the instructions to emit. Although really we could just loop here. Now we're going to have to do some other things when we have functions and etc. But I think this should be okay. Strings.toString. So we're going to... what's it called? The string builder? Oh, just SP. Okay. So for each instruction, we're going to emit instruction. All right, so it's pretty straightforward right now. We don't return anything. We're just going to pass in the state. I think that's what we want to do. So this will be emit. And then we just need to figure out what kind of instruction it is and how to write it. So Right now, we're only really concerned with, what is this? A move, an add, and a divide. So we can do that. So we want to do a switch on the instruction. I have added word wrapping now. Let me see, where's my head? It's over there. I've added word wrapping so stuff doesn't go off the screen as much, but also since we're in Vim, we can do the 20, is it Shift W or Control W? Yeah, but I went the wrong way. There we go. So we can sort of see what we're looking at on the left, and then the program's a little bit more visible here on the right. Nice. All right. So we're going to switch on the instruction opcode. I'll make that a partial for now. We want move. We need add. Yeah, I guess move, add, and divide. I don't know if we actually handled divide yet. Let's have a look. We don't. So why don't we add that? Could add it here to the binary op as well. Slash. Okay. So this is going to add to the string builder a line for the move instruction. So it's going to be something like move, destination, source, and then we just have to fill these in. So what are these? Instruction, I guess we could call it something like encode operand or something. Hello, Oglo the nerd. How you doing? Oh, I don't actually have the chat on the screen. I'm going to add that soon. I've just been a little bit preoccupied recently. Encode the not instruction operand. You're doing pretty good. I'm doing well. Thank you very much for asking. It's a nice sunny day today, despite the, what is the temperature? I don't know, it's like 16 degrees Celsius. So, you know, a bit cold, by Australian standards anyway. So we're going to encode the destination and the source. It's been super rainy where you are. Quite nice. Yeah, I do like the rain when, well, first of all, when I don't have to go anywhere, that's kind of nice. Or if I just have to go short distances. And when I have enough time to sit next to a window or something and enjoy it. But I don't like it when it's raining just a little bit, and then you get a storm that's like 10 minutes, and then it rains a little bit, and then it doesn't rain. That intermittent rain, it's not as cool. I want it to rain like all day or something. Of course, then I'll be sleepy all day. Because I actually wear these headphones to sleep sometimes with rain sounds on. Because my daughter snores. And so I've trained myself to go to sleep when I hear rain. I get sleepy. Yeah, that should work. All right, let's just test this first. So this is going to take an operand, obviously. And it's going to return a string. Now, what kind and what kind? Let's have a look at these. I just need to look at the shape of operand. Alright, so it looks like this. I forgot how to use Vim again. There we go. Oops. How do I don't want to do Z. Okay, you know ZZ, you can arrange the text to the middle. There's like Z top. Okay, but I didn't really want it to be the top. I just wanted to go up a bit. Whatever. It's fine. In Helix, it's Z, J, and Z, K, I think, to go up and down. So, we're encoding an operand. The operand has a kind. There's a lot of last-minute decision-making happening. Alright, so switching the operand kind. If it's none, then that's just invalid, but I'm not going to handle that right now. Register, we don't use memory yet. Or immediate. Okay, so... Excuse me. Okay, so let's say we've got a register that's... Well, let's actually look at what we're doing. So we've got register RAX, RCX, RDX, R8, etc. And we've got some immediate values. So let's just cover these cases. So if it's a register, all we need to do is convert the enum to a string. We can do that in a couple of ways. One way is using reflect. And it's called name from enum or something like that. I wonder if we can, or we can actually just have a list of registers and their names, which is also a thing, like register names here. And that could be an enum array of type string. And of course none is none, so can't remember if that's how you type these out. Let's see. What error do we get? Ah, different error. Undeclared name, none. Oh yeah, right. So this should have a dot, I think. Yeah, and now it's telling me that I didn't handle all the other enumerated array cases, which is fine. So I'll just handle these now. Alright, let's just type these out. RCX, RDX, R8, R9. That's not an 8. R10, 11. Actually, yeah, I guess I'll type them in the same order. See, now I'm going to run into a problem with Vim where it doesn't have multi-cursor. So, got to make like a macro. I can't remember how to do that. So I'm just not going to, I guess. Yeah, it's been too long. It's been too many years since I used Vim. Hang on a second. I have an idea. I'll just open Helix. Here we go. And now you can see why multi-cursor is great. There we go, done. You're writing a text editor in C with native multi-cursor inspired by Helix? Nice. That's cool. How far through it are you? Okay, return, not return, yeah, return, register, names, operand, no, just reg. Okay, that's that one done. Wow, 95% complete, and you post progress updates in the Handmade Network Discord server. Okay, cool. I'll check it out. It's sort of like Emacs. Okay. In what way is it like Emacs? Everything's a buffer rendered in a window, including the window borders. Right. Okay. Yeah, I've heard Emacs users say this everything is a buffer approach is really powerful. I've tried Emacs a number of times, I just can't really get into it. It has custom preemptive scheduler for Lua virtual machines. Okay. Preemptive scheduler. So, what does that mean exactly? Multiple Lua virtual machines in the same process? I mean, that's definitely possible. This is funny. I'm going to turn this back into a string. That's ridiculous, isn't it? Basically, text editor, like Emacs, is single-threaded due to simplicity. Okay. So you use Lua set hook to create an interrupt. Okay. Right. I see. So it doesn't hang when you're doing stuff. Is that right? This is ridiculous. I should maybe just hold on to this string. Yeah, although you do have atomic operations in the editor as well. Okay. Hmm. whatever. I'll just leave it like this. It's just silly that we're converting a string into a number and then a number back into a string later in the pipeline. Total waste of computation. I'm just going to put a to do. You create videos, hoping to do the announcement for version 0.01. Hoping that will do well. Okay, nice. We're developing it for 3 months. Wow. Being 95% complete in 3 months is pretty impressive. Excuse me. I'm drinking that Pepsi again. It's going to make me burp. Passion is powerful. Yeah, it is. It's true. Right, so I need to pass the builder in here, of course. And none of the code is AI generated. Nice, that's good. That should help you actually be able to maintain it. Wouldn't it be cool though, if you built the editor and you were just happy with it, and then you just said, wow, it's finished. And then you just didn't have to update it. I would like that. Chief Sosa says, in this economy, what was I doing? Oh yeah. Where are we even outputting code? We are not, so we need to do that. So we got emit, no, not emit instruction. It's emit program, yeah. No, this part. Oh, that's sort of the idea, to have it finished. Nice. Core is written in C99, but all the opinionated stuff is user-controlled Lua. Okay, I see. Okay, we're passing in the wrong thing. We need to pass in the instructions. Alright, so what do we get? Well, yeah, that's expected. We haven't got an automatic main creation thing. I might just do that for right now, but, you know, we got move RCX 40, move RDX 2, move R8 1, move RAX R8. So that's just not correct. Chief Sosa says, honestly, it's baffling to me that there is no text editor that is ready to go that isn't Electron in disguise. And Oglo says, gonna go have a bike ride. Catch you later if you're still streaming. Nearly 8 p.m. Okay, enjoy your bike ride. Have a good one. Text editor that's ready to go, that's not Electron in disguise. Well, I mean, there's a bunch of terminal-based ones, NeoVim, Helix, Cocoon if you're on Linux, and Emacs, of course. I think, is there a terminal Emacs? Well, whatever. Emacs is its own thing. There's Fred, which is down here. I haven't really gotten into it yet because I haven't had time to learn a new editor. Fred looks pretty good. But it looks like there's a lot of mouse stuff, and I just don't use my mouse if I can help it. So, yeah, maybe there's some misconception on my part. It just seemed like there was a lot of mouse-oriented things. But I'd be happy to be corrected on that. Alright, so this code is just wrong. Why is this code wrong? Because we didn't add any other instruction types. We just added move. And an add is just add. Okay. Oh yeah. I forgot about order of operations, but this still works fine. 2 divided by 1 is 2. So 40 plus 2 is still 42. Hmm. The fact that these all look exactly the same shape. Well, I'll worry about that later. So, we don't have a main, but... Chief Sosa says Z is written in Rust, but you've put an asterisk over the U like it's a curse word. VS Code is browser, nvib is config hell. That's true. That is true. I actually got an LLM to write my nvim config because I didn't want to do it this time. That's why I like Helix, because my config in Helix is like 3 lines or something. So we want to just put a main proc here, I guess. And then... Do we even need a return? I don't think so. What's wrong with this? Ah. Right, of course. What am I doing? New line, and then all of these instructions, they have to have a tab. Which I guess I could just put here. What's wrong with this? Ah, yeah. There's Sea Lion, but you haven't looked into it yet. Might feel weird to pay for a text editor / IDE, but honestly, in this day and age of software, it might not be so bad. Yeah. I've heard good things about Sea Lion, but I've not used it either. I don't really understand the aversion to paying for things. Seems kind of weird. I mean, of course, I use a lot of free software and I'm very grateful that it exists. But if all free software was removed from the internet, as in free as in you don't have to pay for it, not free as in, you know, Libre, open source, whatever. If you just had to start paying for everything, then, I mean, yeah, I think it would feel like it sucks, but also it's weird to expect people to maintain stuff for free for you, right? It just seems like an odd thing. It's like you're not entitled to anyone else's labor. So if they decide that they don't want to maintain it anymore, then that's their choice, and you just have to respect that. Of course, if it's open source, you can maintain it yourself, and that does happen. All right, this looks good. Maybe we should actually try to run this. What does the run script say? Out.assembly. Okay. Hang on a second. I'll paste this here. There we go. Run. Could not open out.obj. Invalid combination of opcode and operands on line 15. Now, is that not the divide? Oh, it's probably idiv or something, isn't it? Let's see. Thank you, Felix Cloutier. No, there is div. Chief Sosa says, if software is good, pay for it, but in my eyes, a text editor is such a fundamental thing and common necessity for all programmers that someone should have already solved this problem. Well, yeah, if you ask different people, this problem has been solved. Ask an Emacs user, they'll tell you it's solved. Ask a NeoVim user, they'll tell you it's solved. Ask a VS Code user, they'll tell you it's solved. So in a lot of people's minds, it is a solved problem, but considering that people are still making new ones, I tend to agree with you that it's not solved. But maybe that's just how it is, you know? We're just going to keep evolving these things over time. Hang on a second. How do I read this? Divide, what is this, r/m64? Divide rdx rex by m64. Oh, wait, hang on. Does this have a set? Oh, does this have set registers? So you've got to put with results stored as in rex and rdx. Right. Let me have a look. That's not the right. What the hell just happened? x64 divide instruction. Yeah, I was just looking at that page. What does it say? Okay. So, unlike most other, both instructions accept only one explicit operand, the divisor. The dividend, the quotient, and the remainder are placed in implied registers determined by the size of your divisor. Oh, okay. So divide is not so simple. All right. So we've got to move into RAX, the number that we're going to divide, then clear all the bits of RDX. Okay. And then move into RCX, the divisor. That's kind of annoying. Yeah, I guess that makes sense. But it's annoying for my model here because now we can't. We've got to either, well, I guess it actually feeds into what we're doing today. If we have a divide, I'm going to push the values that are in RAX, RDX, and RCX onto the stack, and then restore them after the divide is done, and then move the result into wherever the result is supposed to go. So I'm going to say push RAX, RCX, RDX, then pop them pop into, I guess it would be, wait, push them on, pop them off in reverse order. Okay. And then we want to store result in destination. I guess this was is it serendipitous or fortuitous? Problem to encounter. Either way. All right, yeah. What does run do again? Oh yeah. Out.asm. Alright, I'm going to make my main file actually write that. So we can do odin run code and run. And I'm going to get an error, which is fine. Alright, so now I've got to figure out how we're going to push onto the stack. So I guess we call, I think I called it stack push. Stack push. What did I, hang on, this is in the emit. Probably don't want to do it here. We want to do it when we encode the instructions in IR, right? Probably want to do it here. All right. So this can just be, I guess you just, what do you call it? Div and then divides RDX, REX by RCX. Hang on. Oh, we need two 64-bit registers to do a full divide. So it's taking 128 bits. Is that right? Huh. Yeah. All right. I suppose that makes sense. I need to probably think about it some more. But yeah. Right. So we're doing a range division. Why does this look familiar? I probably encountered this making my own assembly language. All right. So we need both these registers for the high and low bits of the dividend. Okay. Gotcha. Which one is it? Low is in REX, high is in RDX. Oh no, we don't store, we just clear. Clear. Oh, hang on a second. That's not what I wanted. Yeah, we just clear it. So we can spill over. I'm sure this would be very obvious with an example. But anyway. Okay. Then we want to load the divisor into RCX. And then we just call div RCX. Okay, got it. Now, is the RCX thing hard-coded? No. So this could be not RCX, it could be just destination. Right, and then we get back... No, we don't get it back in the destination. Okay, the source, the destination is always RAX, I guess, for integer divide, and then we get a remainder of 1. Hundred divided by 3 is 33, remainder of 1. Does that mean we round up? Okay, div source, and then result is in RAX, which is the quotient. RDX, the remainder. Then we can store the result in the actual destination. Then we can pop. We don't need to pop RDX RAX. Yeah. Okay, that should be good. I think that's basically what we've got to do. To do a divide. It's a lot more work. A lot more work. Okay. So we want to reserve. Oh yeah, this should be R10. R10 because we want to save R11 for pushing to the stack when all registers, when all volatile registers are full. Now I've got to figure out how to push to the stack. We've got to keep track of where the stack is at any point in time, I think. Yeah. Stack offset. In this case, do we need to return anything? I'm not sure, because the stack push... if I remember, it's always 8 bits, right? 8 bytes, not 8 bits. Oh, wait, this page. I was reading something about this before. Here we go. Stack Overflow, it's still alive. NASM allows push dword 123, even though it doesn't set the operand size, it's still a quad word. So, even though you push dword, it's still 8 bytes. But push strict dword 123 makes sense to set the immediate width. For performance, move RAX, immediate 64 / push RAX is best. Okay. Fetching a 64-bit immediate from the UOP cache can take an extra cycle. Alright, but still overall worth it. Don't write push dword in your source code. It's misleading since you literally can't make a push. Only move the RSP by 4 in 64-bit mode. It's always a quad word push. Okay. So, in that case, when we use a push, we're actually pushing... This is not the correct terminology, I think. Stack push. At least not like this. So what we want to do is go back to, where were we? Up here. So when we push RAX and RDX, we specifically do want to push these. So, I mean, the easiest way is to just make this an explicit instruction, right? So we're going to push, and the source is what are these even called? Kind register reg equals RAX, is that right? I think that's the right structure. Okay, and then, whoops. Same for our dx. All right, and then we want to clear rdx. Okay, and then store, well, I probably should do it in the order that I wrote it, just because. I feel like this should be a helper procedure rather than appending an instruction every time. Like, you know, make a binary operation or something, and then XOR RDX, RDX kind of thing. That would make sense, right? Should I do that now? Let's see if I can get this working first, and then I'll worry about that. So we want to store the dividend in RAX. Okay, that's fine. This is a move, destination, and the source is... Where is the source? It's, well, here. Source is source. Okay. Is that the right? Is that what we're storing? Yeah, that's right. Yeah, the dividend. Okay. Now the divisor... Wait, load divisor into source. I've confused myself now. I think we'll do DST here. All right, and then what does that look like? Let me just put these in the correct places. So push the values, clear the bits, load the divisor into the destination. That was... Did I not do that just now? Ah, no, I didn't. Alright, so it's the same thing as above, but we're going to put it into destination. That should work. Oh no, hang on, this needs to be destination. And source is... I need to look at how this actually outputs now. Okay, so we moved into RDX, the value 2, and then we moved into R8, the value 1. So this is the... Which one is this? Whoops. Yeah, I guess destination. But this needs to go into, where does this need to go? I need to read this thing again. Where was it? Yeah. You know what? I might just use RCX in this case. So RAX, RCX, RDX, push those. Then I will move into RCX, the value I think it's DST. So I've moved the source into here, destination to here. Yeah, I think that's right. Maybe I shouldn't have called them source and dest. I should call them left and right or something. Anyway, okay. Now we can do the divide DST, and then the result is in RAX RDX, and we can pop back RDX, RCX, RAX. So now we can store the result in the destination. So that'll just be a move from RAX into destination. Then we can do the pop. Okay. Not poo. Definitely don't want to do a poo. Alright, so we do pop, and this is going to be destination register equals RDX. Alright. So we've got to do 3 of these. Oops. I don't like that behavior. When you paste a block, the cursor is not at the bottom of the block, it's at the top. Anyway. RDX, RCX, RAX. Okay, I think in theory that should be good. Now I'll probably mess up some things. So let's see. Okay, we don't have a pop, we don't have XL, we don't have push. But it looks like that's all I messed up, which is surprising. Alright. Where's add? Alright, XL, pop, push, oh, push, pop. Okay, now these are not handled anywhere. I think... Well, I guess we're handling them here. Oh, yeah, we're using them here, so... Okay. Yes, yes. Now we don't actually know how to print this out yet in the emit code. Let's have a look at that. So we need XL, push, and pop. Alright, so XOR, pretty straightforward, I think. Yeah, just the same as this. Which means really we could make these the same thing. Add div, no, not div, XOR. Instead of move, it would be, what did I call them? Opcode names? Where did I put that? I didn't do that yet. Okay, I'll do it now. opcode name. So that can be add, move, and... no, this is going to be a problem, isn't it? Actually, it might be fine. Might be doing this too early. Might be doing it too early, but we'll see. Opcode name is an array of strings. Move is move. Add is add, etc. I have to get all of them, don't I? This is what we got. Move, add, div, XOR, push, pop, and invalid. Okay. Okay, it should give us all of the opcode names. Now for push, it's very similar, except we only have one operand. If I could type, that would be awesome. And I think that's all we need. So we'll just add, well, no, I don't need to do that. I'll just type push. Push. I think it can only be, actually, I don't know if it can only be a register. Instruction dot source. Okay, how do we go? Messed up. Opcode name. It's not a procedure, so we can't call it like a procedure. That makes sense. I forgot the div. All right. All right, what do we got? Move into RCX40, RDX2, move into R81, push RX, RCX, RDX. Excuse me. Move into RAX, RDX, XOR, RDX, RDX. Move into RCX, R8. Right. Move into R8, RAX. So that's the destination. I don't know why there's two tabs. We must have missed something. Oh, the div. We got the div. I think that's the right thing. Yeah. Now move into, wait, move into R8, RAX. Yeah, that's right. That's right. So, etc., etc. And then add R8, RCX, move into RAX, R8. Okay, interesting. Why do we get this error code? Not error code, exit code. So when we move the value from R8 into RAX, and then we come out of main, it should be an ECX because it's really 32-bit number. It's not larger than a 32-bit number, I think. And then we call exit process. So we really should be getting a small number here. Let's walk through the debugger and see what is going on. How do I do that? What is it called? Out.exe. Probably this one. All right. Whoops, I didn't go into main. Where is main? Well, actually, I guess that's fine. So we're moving into ECX, the value 42, no, 40 and 2. Okay, let me look at the registers. Oh, they're already open here. So I want to see what's in RAX. All right. Okay. All right, so I just popped into RAX pointer. Did I do an asymmetric amount of pushing and popping? 3 pops, 3 pushes, RAX, RCX, RDX, RDX, RCX, RAX. Yeah. Why did I get a pointer? Okay, let's look at how pop works. Maybe I misunderstand. Okay, it removes it, copies it into a destination operand, such as a register, and automatically increments the stack pointer by 8. Yeah. Okay, can I look at the... Let's try this again. Can I see the stack somewhere? I guess it will be in memory. So I'll just look at this pointer. Oh, okay, we're just doing something weird now. Right. What's going on here? What the bloody hell's going on? Yeah, that didn't look good. That looked like the program was definitely not doing well. Like int3, that's a trap. Why did we hit a trap? Like straight away, we didn't even do anything. Okay. Okay, we're gonna subtract from the stack pointer 40. Okay, where is it? RSP, it's 0. Now it's... No, it wasn't 0. It was whatever that number is. Now we're aligned to 16. We can do the call. Now we go into the call. Okay, now we're doing main, right? Etc. Alright, so we just push these values. Okay, stored in RAX was this number, which is the return... Is it the return position? Oh, I see. Hang on a second, let me look at the calling convention again. Okay, so let me look. RAX. I thought it was the return value. Okay, RAX, R10, R11, XMM4 are considered volatile or potentially changed by a call E on return. Changed by a call E on return. Right. Register usage is in here. Return value register. That's what I thought. Okay, let me step through this again. All right, so we're gonna subtract. So let me look at the code. Well, I guess this is the code. Subtract from RSP 40, and then call main. Okay, so RSP is now aligned, right? Because it ends with 0, so that means 16 byte alignment. And should have enough space to store whatever needs to be stored. Okay, now going down to here, this is main, I guess. Well, this is main, right? That's main, that's main. Why did that go into there? Okay, I'm going to start it again. Let's look at Rx at the beginning. Okay, right at the start, it's got this number in here. Okay. Oh, yeah. Oh, hang on. I'm being stupid. Not really surprised, eh? So this number is in here. Right at the beginning, because did all this code run? I don't think so. Or maybe it did. I don't know. Did we really run that many thousands of instructions first? But it's just the same thing over and over again. Okay. So we're going to push this pointer to the stack. So it is actually working as expected. Okay. And now we're overriding it. And now we don't know where to return to. Is that the problem? That could be the problem. Also, I didn't put a ret as in a return instruction. So let's do that, I guess. Main. Oh yeah, I was going to do it this way, hey. Use the format library instead. So we can just put a ret. Alright, 42, yeah. So the problem is we didn't actually return. It turns out that's not optional, funnily enough. Otherwise it just goes off the end of main into a bunch of, well in this case, trap instructions, int3. Okay, cool. So we have returned from main the value 42, which was the result of this expression, 40 plus 2 divided by 1. And that is a working program that also uses the stack. Well, we're manually using the stack right now, which wasn't really the goal of this stream. So we've only been going for an hour. We can go for a little while longer, I think. And we can get... What I want to get working before the end of the stream is automatic stack pushing and popping based on what, you know, having more variables here. So if you have like, you know, y is 1, 2, 3, I'll just make this simpler. Z is 2, 3, 4, and then W, I don't know, 888, and then 999, WX, wait, going backwards again, AB, well, whatever, PQ, point is, eventually, 1, 2, 3, 4, 5, 6, 7, 8. Eventually, we're going to run out of out of registers. Well, in my system that I've made here, there's actually way more registers I think that we could use, but I've made it so that we can only use. Where is it? It's in the bottom of this file somewhere. So we can use the register up to R10, up to and including R10. R11 is saved, so if the register, yeah, so in this case we're going to return false, right? So if we use all the registers when we reserve a slot, we're then going to push to the stack. So that's what this stack push is supposed to be doing. I just haven't figured out exactly how I'm going to do this yet. We need to keep track of what's pushed to the stack, I suppose, right? But my idea was we'd put value in R11, push that to the stack. and then refer to it by stack offset. I think you can do that. So you don't have to, I think once you push values onto the stack, you don't have to, like if you wanted to access P and you've pushed Q, R, and S after, I don't think you have to then pop S, R, Q, and then P. I'm pretty sure you can just index into the stack pointer and copy this into a register by RSP, stack rows down, RSP minus the offset, right? Something like, you know, move into, like I want to look at the stack variable or I want to do something with it. And let's say I want to add two numbers together. One of them is in RCX right now, and the other one is on the stack, you know, 64 bytes down or something. I think you can do this. Yeah. And then and then at the end of the scope, you would just pop everything that you pushed. So you'd make it symmetrical that way. Yeah, I think that makes sense. Man, this stuff is challenging, but fun. What's wrong with this? Oh, I probably broke the code. Wait, how did I break the code? Oh, because I added too many things. So now it doesn't have anywhere to put them. We got to R10, and now it's like, I don't know what to do. Don't have enough register space. So yeah. So in my game, which I realize I've talked about a bunch of times, but I haven't actually shown it. So let me see if I can Google it. Yeah, this other game came out that has the same name, Track and Field Coach Simulator, which is interesting. Anyway, my game's not out yet, so doesn't matter, I guess. But let's see the programming screen. So it's really simple. Well, it's really nice to be able to have a limited scope for your machine. So this is a quad-core microcontroller with sort of a RISC-V style assembly language and virtual machine. And it's just got 64 bytes of memory. So when you want to store something, there's no stack. You just store it in one of these bytes. You just put the address here, store 0, whatever's in register 0. Right? And that's really nice. Of course, we're doing real programming here, not fake game programming. So we're going to have to do stuff that's a bit different to that. All right. I'm just going to grab another drink, and then we will look at doing this, putting things onto the stack auto-magically when we reserve a slot. So anywhere we've called reserve slot, like here, if there's not enough register space, it needs to fall back to stack allocation. And then, yeah, that should be fine. I don't know who determines how large the stack is. Is that Microsoft thing? Or is it something I can change myself? How to change stack size of x64 Windows program. Yeah, I knew it was going to give me an answer like this. The default stack size is typically 1 megabytes on Windows, I know that, and 8 on Linux, I believe. But then they're just telling me, oh, you can change it with compiler flags. It's like, okay, but I'm making the compiler, so, you know, how do I do that? Although it looks like it's a linker flag. It's actually a linker option. Oh, you can change it in configuration properties, linker system stack reserve size. Wow. Anyway, so if it's a linker option, then I'm not writing a linker, so I should still be able to use this option later if I want to make the stack size larger. Okay, good to know. Right. All right, I'll be right back. I'm gonna grab a drink. All right. All right, here we go. So, when we reserve a slot, actually, I have an idea. Maybe we don't need to keep R1. Not R1, R11. I don't know which one's better, but I need to look at the move instruction. Although I'm having a hard time reading this specification that Felix has put together here. So I want to look at, let's look at move. Okay, move. Right. Move immediate to R16. Move to seg offset. I need to just look it up here, I think. X64 move until I figure out how to read that page properly. Can we move to stack address? Is that a thing? You can write data to stack address by using move, by dereferencing the stack pointer or the base pointer register using square brackets. Can we also offset it though? Yes. Nice, that's what I wanted to know. Right. Okay, interesting. So I forgot about the base pointer. So the stack pointer and base pointer. So do we want to store, we probably want to store the absolute offsets when we allocate something on the stack. So it's the offset from the base pointer and we would subtract it. All right, cool. This is useful. So we could do something like, rather than, well, yeah, sure. That's fine. I don't think we need to do this then. Because when we reserve the slot, we want to get the space first, and then we want to use it. That's how we've been doing it so far, right? Like this. So when we reserve the slot, all we need to do in this case is, I guess, push 8 bytes to the stack. Because that's all we're dealing with right now. And give us back the absolute offset, which means, okay, the absolute offset. If we're going to keep track of the absolute offset, that means every push and pop needs to go through these procedures so that we can keep track of it correctly. Otherwise we'll get, you know, other code paths updating the offset at various different times, and it will just be way too hard to keep track of properly. So this is going to be the stack offset, and that means when we emit this program here and we do this sub RSP40, this has to be accounted for. So I'm gonna grow the stack offset, subtract from RSB to get RSP. I think that makes sense. But it does mean at the beginning, we're going to have to set it to 40, and this is going to be kind of, this is error prone, right? So if we ever modify this emit code here, it's going to be error prone, but okay. Well, we'll just leave it there for now. Potential error prone due to hard-coded value in emit. Yeah. I suppose I could change this to... Oh no, I can't do that. That's fine. Yeah, we'll just leave it like this. That's fine. Okay. So we've seen that there might be an error there in the future. Hopefully when, or if and when that happens, I'll remember that. Now what we want to do is, everywhere that we used push directly here, yeah, we don't want to do that anymore. I think it might be time to make the helper procedures. Make a binary operator. Now, do we need to pass in a state? No, I don't think so. We need the opcode. We need the source and the destination. Actually, I'm going to change this to be, well, register, and this is going to be a group. So we're going to have a procedure group here. Oops. It's kind of annoying. I think maybe this is not the best way to do it. And we're returning, what are we returning? Instruction. And why am I doing it this way? Because I don't want to type this all the time, but maybe that's not the best idea. Let's see. So we're going to make a register-to-register binary operation. That means instruction opcode equals opcode. That's fine. Source equals kind equals register. Register equals source, and then same for destination. Now the problem is we've also got, like, you know, moving immediate values or doing something to immediate values, and then memory lookups, and then there might even be stuff that I don't know about. So I might have to make a whole bunch of these little procedures. Oh, do that thing again. All right, there we go. So I'm going to say register, that's the destination, and then immediate. Yeah, sorry. Destination register, source number. I think this is wrong. I do need a wrapper, but I think this is wrong for some reason. I don't know why. My intuition is just telling me that it's not correct. What if the wrapper was, let's look at the call site here. So what if the wrapper was make unary, and then we just, I guess we do pass in IR. Push. Then we have to know what the kind is. Register REX. Alright, that looks okay. And let's have a look at binary. Make binary. Obviously not push. Let's go down here and find one. So this could be move. And then we've got the kind and then the actual data. So it could be. So what I don't want to do is just type in this. Even though, you know, it's correct. Maybe that's fine, actually. I would rather have something like this. Register REX source dot kind source dot. Well, actually, I don't even know what's going in here right now. So maybe it is better to have this, and we can handle the operand inside the procedure. So then this would be. Is that really that bad? Not really. Okay, we'll do that. Let's get rid of this. I'm calling it make unary, but it's not really. I mean, I guess it is. It's more like appending a unary operation, but that's fine, I guess. So we've got the opcode here. Then we need to have these. Well, it's unary, so operand. Then we simply append to the instructions. We don't actually return anything. The instruction opcode equals opcode, and this would be source, I guess? No, destination? I gotta figure out which one I'm going to use for unaries. Probably destination, because it's on the left. Okay. Maybe naming them source and destination in the first place was a mistake, and they should be like op1, op2. Because if you name them source and destination, you've now implied a relationship between these operands and the opcode that might be different depending on the opcode. This is basically the same. So I can just copy this, put this here. All right. Now, what's the difference here? Excuse me. The difference is I can... No, that's fine. Can't even remember why I was doing this now. Something to do with push and pop. Oh yeah, because all push and pops have to go through our stack push and stack pop, which actually has nothing to do with these other procedures. I'm not sure why I was doing that. Was there a connection? Maybe. Alright, so we're going to reserve the slot, you know, for each number, etc. That's fine. We're going to update the stack offset every time we push. That's fine. And subtract, of course, when we pop. These are always 8 bytes, though. Is it minimum 8 bytes? Let's have a look. Actually, it doesn't really matter right now. Well, maybe it does matter, but what I'm thinking is, if it's always 8 bytes, we don't need its size, but later, when we actually want to allocate more bytes on the stack at once, I'm pretty sure we can just subtract the stack pointer, right? So that could turn into, I'll just type it here. If we want more than 8 bytes, do sub RSP, you know, bytes. Because that's what we're already doing, okay, to allocate that 40 at the beginning. Otherwise, well, I guess that's what we're doing here. Anyway, we are doing that. Okay. So when we do a stack push, we're going to do make unary push. Oh, we're supposed to push something onto the stack though. Okay, I'm conflating two things here. I'm conflating pushing onto the stack and allocating onto the stack. I shouldn't do that. So pushing onto the stack shouldn't have a size. It should have a source operand. And stack should have a destination of some kind. Okay, and then stack allocate should have a size. Don't know if I really need the, I guess we need the offset. It's not the new offset, it's the offset that we can write into. Which, actually that is the new offset, isn't it? Or would it be the new offset minus 8? No, it would just be the new offset. I'm just trying to think about this. Since it goes down, right? We've got address 0 and address, I don't know, 16 and not 32, 24, 32, and then we want to allocate. Okay, let's just actually say we're here. We've already used these. Why did I go up by only, there we go. We've already used this space. Okay, and we're sitting at this position here. Or I guess technically the end of this row, or the beginning of this row, whatever. We want to allocate 16 bytes on the stack. Or let's say 20. Actually, not 20. Let's say 10 bytes. So we're going to use up all of this. And then 2 of these, but then of course it needs to be aligned, so these are going to be taken away. And then, since we moved down... but we didn't move down. So this is like going the wrong way. See? Alright, so what we actually wanted was something that looks more like this. And we start at the top. So we've used this space. Let's just say we've used these 8 bytes and we're here and we want to allocate 10. So we're going to say we get those 8 plus 2, and then these are all taken. As well. So when we do that, the stack point is going to be here. But the space that we can write into actually starts up here at 24. But because we write sequentially the other way, I guess we would return the current offset. Is that right? God, why am I confusing myself so hard? Return new offset to write into. Yeah. Right. So usually when I think of allocation, it's like you allocate some space and then you return the start of that space. But because the stack allocates down, you return the end and then you write into that block. I think that's right. And that's how you get stack smashing, right? Because you allocated some space on the stack and the other data is sitting technically after, but you write too many bytes into it, then you've smashed your other data that was on the stack. Okay. I just got to write this here. Just a note for myself. Really wasn't complicated, I don't think, but it's fine. And of course, deallocation is not the same. It's like from the bottom up, so we can't just deallocate random blocks. I mean, I guess we could. You could just have an allocator that works in the stack. I don't want to think about that right now. Because it's just a block of memory, right? So, could do that. Alright. Okay, so I guess the convenient thing is, at this point, that would be RSP, after you've allocated the memory. Okay, so we've got allocation and we've got pushing and popping. So pushing and popping is pushing and popping a value, like what's in a register or something from memory. or an immediate value. And allocating and deallocating is different. So what this would actually be, I guess, is not a push or a pop, but a subtraction. So make a binary sub, and the destination is RSP, and the thing that we're subtracting is going to be an immediate value, which is size. Okay. Now, this is going to be an add, and it's just the same thing in reverse. Man. Take care of your teeth. Take care of your teeth. I thought brushing your teeth was optional. Because, well, I came from a background where, let's just say, people didn't really care about their health in my family. Yeah, that was not the case. I thought it was just if you wanted really white teeth, then you brush your teeth. And I was like, they're not really that yellow. Yeah. Anyway, I got gum disease. Don't have it anymore, because flossing actually fixes that. And a bunch of cavities. And one of my fillings just came out the other day. So now when I drink cold things, it's really painful. Or hot things. Alright. So we haven't actually pushed the thing onto the stack, so we want to make this unary operation, which is push. And we'll just pass in source. And same for pop. Cool. Right, yeah. Given the name, source, and destination was probably a mistake. Probably a mistake. Should I correct that mistake now? No, not yet. Let's see what's broken. Okay. Right. So, gonna convert 8 to operand. Yeah, that makes sense. There's a random Y somewhere in the source code. At the end of this line. You know, when I first started programming a compiled language, it was amazing. Because I'd basically only done, well, I had only done web development, so PHP, JavaScript, I think Elm at that point. I'd probably done Elm in 2019. And, you know, dabbled in other stuff, but it was always interpreted or scripting languages, Ruby, Perl, etc. So then when I wrote C for the first time, and I realized, oh, if you break your code and then you try to compile it, you just get all of the errors, and then all you have to do is fix them, and your code works now. And it's correct. I mean, as long as the code that you wrote was correct. It was just a totally different world, right? Because, you know, JavaScript just runs unless there's some catastrophic error. You just don't even know that there's problems. So, yeah, pretty cool. I guess these days there's TypeScript, right? So at least you've got type checking. Okay, so binary is supposed to take an opcode, source, and destination, but what did I put there that I didn't like? Ah, right. Yeah. So it's supposed to be not strictly a register. There we go. Cool, there's no sub yet. And this doesn't take a size because it takes an operand now, which is kind of a problem. Yeah, this is not going to work how I want it to work. So what we're going to do here is not this. I think I'm just going to delete that. And I'm just going to allocate instead of having stack push, I'm going to use stack alloc 8. That'll give me the offset. And then I can return I don't even know how to return this yet. Alright, I'll worry about that later. Undeclared name sub. Okay, so the opcode. And apparently I've messed up the braces somewhere. Right. Missing return statement at the end of stack alloc. Okay. Oh yeah, okay, so... Oh, that's simple. We just return this value, which means, do we really need to return it? Don't know. What's the point of returning it on the dalloc? Not sure. I might remove that later. Alright, and now the emit code. How am I getting hungry again? I need to eat more voluminous food. Alright, cool. So, all we're doing is allocating space for these. When do we run out? We run out at 23. Cool. So, we actually need to solve this problem of not knowing what to return here. Okay, so we reserve a slot, we get back an operand. I think maybe what we want to do... Oh, jeez. Right, if we get back the register RSP, we also want to write the value, which is the offset. I think that makes sense, right? No, it would be RSB, the base. I think... Yeah, although a lot of the assembly code I look at has RSP minus whatever, I think I'm going to go from the other end in this case. So we're going to say we'll return, I guess it's a register, but we're going to use both the register and the value, which is maybe good that it's not a union anymore. So the register is RSB, stack base, I guess. And then value is offset, true, and this should be if push is okay. Actually, I can just return push okay here. And if it's not okay, we can handle that here at some point. I'll just type it in right now. If it's not okay, then I'm just going to print an error. unable to reserve slot. I don't really have any information about that. For node, I guess the token. Yeah, actually there is line number and column number. Node.token. I think I called it row. Okay. RSB? Is that not? It's called RBP. Yeah. Base pointer, I guess. Oh, we got a 40 at the end. I don't know how we got a 40. I guess this value is in RAX at the end, the X. Yeah, that makes sense. If I change this to a 42, do we get a 42? We do get a 42. All right. So what have we got? We're missing a bunch of instructions. Okay. We're missing an instruction. No, here, here, and here. I can see that because we put the tab in the emit code at the start of emit instruction, I think it is. Or just the start of emit. Like here. No, not here. Is it the old one? That might be the old code. Here it is. Emit instruction. Yeah. So this is actually showing up here. I might even... I don't remember how the comments work. What I might do here is print line... SP print line. I might just print a little end of line thing. Can't do that. Oh, because I didn't pass in the string builder. Alright, there we go. That's really ugly. Really ugly. What I might do instead is put here e.sb. I can't remember the structure of a string builder. Where is it? String builder. Oh, it's just a buffer. Okay. Alright. Buff. Okay. Whoa. Oh, hang on a second. Is it dynamic? Yeah, it's dynamic. Okay. So, length. Now I can go down here and say if len e.sb.buff equals length. Then print this. So it doesn't do it on lines that worked properly. That should clean that up a little bit. There we go. You can see we're missing instructions here, 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 here. All right. What instruction is missing? So move R9, R10. Let me go from the bottom actually. Return. Move RBP 25. Move RBP, RBP. Wait a second. Why is this being generated? That doesn't seem like a good thing to do. Or it's just wasteful. Move into RBP to value 23. That's definitely not good. Definitely not good. Where did I write that? Oh, I guess here. Because I got the slot, and I printed the slot. Where is it? Is it not this? I thought it was this. Slot source. No, that's a different thing. Oh, it's this one. Yeah. Oh yeah, I gotta do a special case handling for this. Okay. So if we're doing RBP 5672, we don't just move into it. So where do I want to handle that? Yeah, I guess in the emit code. What have I got? Encode operand. We've got encode operand here. So if it's a register, we've got the register name. But if it's RBP, we don't want to return the register name. We want to return something like RBP minus or plus offset. The address that's inside RBP plus offset. Wait a second. Yeah. That's going to get the data that's inside RBP offset, right? I think so. Okay. So in this case, we want to return RBP plus some number, and the number is operand value. Okay, definitely got a problem here. So move into the address that's stored in RBP plus 48 to value 23. Does that make sense? Is it the address that's stored in there, or is it going to be this address? Is that the dereferencing? Because I want to do pointer arithmetic here. Let me just ask Google. Is this correct? No. It's ambiguous. Doesn't know the size of 23. Must specify whether it's a byte, word, D word, or Q word. Instructions generally cannot move an immediate constant value directly into a memory address without a size. Oh. Using NASM. Okay, so you can fix this by using the size. All right. So I'm just doing 8 bytes right now, so I'm just going to make it a Q word. NASM, I don't need to add the pointer. Yeah, okay, fine. Did it actually give me an error? It did. Line 28. Right here. Wait, line 28, but not line 27? Oh, yeah, right. That's definitely not valid. Apparently this is valid, though. So it's not even complaining about this. I wonder what... No, this is definitely not okay. I'll have to figure out why that's being generated in a second after we fill in whatever these are supposed to be, which I think are sub RSP operations. So let's handle those first. We don't handle subtraction anywhere. Okay, is that done now? Wow, that was easy. Okay, so it's still not correct. Line 22, invalid combination. Oops. Sub 8 RSP. That's the wrong way around. Yeah, wrong way around. Okay, so when we're creating the stack allocation, here it is. We want to swap these around, I guess. Wait, what? Sub? How does it end up on that side? Ah, because I put source first in this. That's not good. Alright. Alright, line 20. Okay, we've got the same problem as before, but this looks better. Yep, that looks good. That looks correct. Now we're probably going to run into this problem where the stack has always got to be aligned, but is that only when we do a call? Don't know. We'll run into that eventually. So we can move into RBP to value 48. Sorry, RBP plus 48 to value 23. Move into R10, this value. And then make space for this one. Okay, I need to figure out why this is happening. Let's see. So I'm looking for 56 and 64 on the same line here. Well, there's 56 and 64. All right. Is there any way I can simplify this? It means we're trying to allocate space on the stack, right? So we must be calling reserve slot for I'm actually going to just print the value that we got out. I need to figure out where this is coming from exactly. Although, if I just run it through the debugger, I should find out, right? Why don't we do that? So it seems to be just after we move 24 onto the stack, the number 24. All right, let's see. Need to go into main, there we go. All right. So, oh crap, what's 24 in hex? I can't remember. 24 is 0x18, okay, yeah. Okay, so it's this one. Oh, I'm doing the wrong thing. I need to run through the compiler, not the output code. Okay. So we probably want to run into here. It's all going to be variable declarations, right? And then we're just appending. It's going to be here. Okay, we've now got, what is this? I can't see the node token text, unfortunately. Node? No. Let me have a look at the watch. Window node.token.text. So this is X, as I suspected. So let's see, what are we looking for? So it's just after the 23, no. just after the 24. So after R goes in. All right, let's have a look at the state. Just before R, which is Q, P, Q. All right. What have we got? Ah, not really many locals. IR. Stack offset's currently 48. All right. Okay, we're looking at R, which is the last good one. I feel like I missed a whole lot of stuff just then. Maybe I need to go in here. I'm going to skip past. Lower, go into, maybe put a breakpoint in number. Yeah. All right. So we're reserving a slot. What slot did we get back? We got, how did we get RAX? That doesn't seem right. And the value is also 1. Okay. All right, what did we just print? $72 and $80. What the? All right, that was the next one. So we went past it. All right. Now, let's just run this from the beginning. Unfortunately, we've got to go through all these values to get to... Well, I guess we don't have to. We could modify the code here so that we just stop at RAX. So then it's going to break right from the beginning, right? Yeah. All right, so the first one, straight away. Yeah, that one looks good. Then... What the? Hang on, I'll change this to greater than or equal to RAX. Run this. Alright, so the first one is broken. So allocate 2 slots on the stack. One for the left operand, I guess. And one for the right operand. But there is no right operand. Alright, let's walk through it. Alright. Stack offset's currently 40. That's good. We haven't done anything yet. There are no instructions. Okay. So we're back in lower and we're doing a variable declaration. Go into reserve slot. Go into reserve register. So if it's none, then continue, that's fine. If it's greater than or equal to RAX, then break. Then we return none, correct? Okay, we didn't get a register back. So now I've got to push it straight onto the stack. So we're going to allocate 8 bytes. Let's go in here. All right, so we increase the stack offset. We make our binary operator, binary instruction. Okay, let's just have a look at these values. So destination is RSP. Is that right? I'm going to look at them over here. Destination, source. Okay, source is 8. Okay, so, and it's an immediate, right? Yeah, immediate value. Destination is RSP. That's wrong. Is it not? No, that's my bad. It's supposed to be RBP. As in, I think it's RBP, right? Yeah. Okay. Wait. No. It is RSP. What am I saying? Yeah, it's RSP because we're going to subtract the size from RSP. Okay, yeah. Of course, that's this instruction here. Okay. All right, let's go through this again. I'll just put this break here. All right. Okay, so that's the first one. And then I guess we got back, it was okay. And the offset is now 48. That's correct. Now we're going to do return RBP with the offset and pushes OK, right? That makes sense. Okay, so we've reserved the slot. RBP, good. Now, we need to figure out. All right, so we've got the slot, which is the destination, basically, of where we're going to store something. The source, in this case, well, let's go into this. All right, so we've got a number. We have to reserve another slot for where to put the number. I will skip over this and see what we get. Actually, it's already doing it for me. 56, right? So we're going to return somewhere on the stack. I see. I see the problem. I'm pretty sure I see the problem here now. All right, and now we're returning RBP. Why is it like that? Slot. Okay, apparently the slot is 79. What the? All right, hang on a second. Okay. Oh, reserve slot failed. Didn't print anything. It says reserve slot, reserve OK is 0. Am I looking at like a stale binary or something? What's going on here? I'm going to delete What is it even called? Code.pdb. Okay. All right. Reserve OK is not true. Slot is garbled memory. Hmm. I don't think that makes sense. Okay. I'm going to print something out here. So reserve slot, whatever, for, no, that's fine. I'll just put the line in the row. And we're going to print out the slot. There we go. What did we get? Ah, I didn't use printf line. Okay, reserve slot RVP value 136, 152, 168, etc. 56, 72. Yeah, so it's not garbage. I think I might need to restart this. Let's have a look. I also need to recompile. Actually, no. Oh, yeah. Build. Let's try this again. Okay. So the variable declaration slot is 1, and that looks correct. Okay. That's fine. Let's go to the next one. So what do we get back for the number? 0 and garbage memory. Why is that? Like, I don't think that's what's happening because it does, the program works. It's just the output assembly doesn't work. All right, I'm going to leave that for now. I'll have to do some other kind of debugging, which is annoying. But okay, it happens. Okay, so we reserved the slots, and I said I think I know what the problem is, and then I forgot. But let me think. So we're going through this variable declaration up here. Then we're lowering the source, which is an expression, in this case a number. So I'm making a slot for it as well. But since we ran out of space, the source and the destination are both on the stack. And it's just not invalid. So interesting. So this is not a valid code. Or not a valid instruction because you can't have the destination and the source both being stack pointers, I guess. Well, how would we fix this? We could use a temporary register. So that could be what R11 is for. So every time we run into this situation where both the source and the destination are on the stack, we copy into a register this value, and then we copy from that register into this slot the value that was in the register. I want to see if there is a direct move for x64. Is there a stack to stack move in x64? No. So you're supposed to use a general purpose register as an intermediary. Yeah, okay, that makes sense. All right. Well, in that case, we'll use R11, I guess, for that. Just to get it working. I don't know if that's the best idea, but how do we make this happen? I guess when we make the, well, it's not a binary operation, right? It's literally this move here, which is a binary operation, I guess. So I'm gonna wrap this. Did I call it binop or binary? Binary, okay. Make binary, move, and then it's gonna be, well, dest source. But in this procedure now, I'm going to say, all right, if dest and source are both stack pointers, then use R11 as temp, you know, area. That makes sense, I think. So we're going to just say, I guess I can do an if. If source.register is equal to RSB and destination.register is equal to RBP. Why do I keep getting that mixed up? Okay, so they're both offsets on the stack. That's the idea. Offsets from the base. Handle RSP, probably. So if they're both RBP plus some offset, then what we want to do is actually append another instruction here. And this is going to be a move. Well, I guess I could just call this function again, but whatever. It's going to be a move. Destination is R11. Kind equals register and register equals R11. So this might cause some issues in the future. I don't know, because now this language has this, property where R11 register is going to be used for stack to stack copying, and that's just how the language works, which I don't know if that's going to be a problem or not. Source is going to be source, I think. Let me think. So we want to copy into R11, the source, and then copy into the destination what's in R11. Yeah. I'll just put this in an else block. Okay, so that's that one. And then, of course. Really, I could just call this again. Whatever. So I want to move that into there and then move from R11 into destination. Right? Yeah, I think that's right. So it's 2 instructions instead of 1. Now R11 is no longer safe to use for other purposes. What's wrong with this? Okay. What? Parameter source of type operand is missing. Okay, we need the opcode, destination, and source. What did I put in there? Oops. Opcode, destination, and source, yes. Oh, and IR, right. Okay. Okay. Destination is not what this is called. What did I call it? Slot. Alright, now we've got... Okay. Move into this stack position, the number 42. Move into R11, this stack, whatever's in this stack position. Then move into this stack position, whatever's in R11. Then make more space. Okay, that looks good. I think. Because this program doesn't do anything, it just moves stuff into the stack. But that looks good. Let's see. Greater than or equal to, yeah, greater than R10. So save R11 for pushing to the stack. So actually I did end up having to do this, but not in a way that I was thinking about it. So the comment is not rotted. Okay. So we got up to 7 values, right? 1, 2, 3, 4, 5, 6. Oh, 6 values, I guess. 6 values, 7th value goes in the stack. And etc. Cool. Now if I run the program, it runs forever and then has a crash. Well, it doesn't run forever, so it crashes. Why is that? There was no linking, there was no assembling error. I'm probably overriding some vital memory on the stack or something. So let's have a look at that. Now we're looking at the output program. And let's just make this smaller. We don't really need to see that at the moment. All right. So, all right, move into ECX this value, etc., etc. Now I've got RSP sitting at this number here, and the base pointer is 0. Hang on a second. That's not good. This is going to be, just is going to move it into memory address 30. Okay. I have misunderstood what RBP is actually doing. That makes sense. Let's look it up. Register base pointer or frame pointer. It's used to anchor and manage the stack frame of a function, giving the program a stable reference point to access local variables and parameters while the stack pointer shifts. It holds the base address of the current function's stack frame. Offset values from RBP reliably locate local variables. I see. Right. I was thinking about this in a totally different way, which means this is not correct at all. Alright, so the stack point is sitting at this position. It also means it's not aligned. Interesting. Why is that? It should be. Because of this line here. Okay, yada yada yada. Alright. Well. So RSP just went down to E0 from E8. Can we look at that? In the memory viewer here. All right. And obviously this is going to fail now. All right. Okay, so this didn't do what I thought it did. RBP. So I'm going to change it to RSP, and then it's going to be totally broken, I think. Right, because the offset's going to be reversed, I guess, or inverse. Well, let's just see what happens, eh? Ah, I just need to run this. I don't need to do that. Yeah, that's wrong. What is that about? Oh, I must have had a special exception in the emit code here. Where was it? Here it is. Now, is this going to be plus? This is going to be relative offset, though, not absolute offset. Let me think about this. Do we know the address of the current function's stack frame? And if we do, how far down from that does the stack begin? Alright, well, let's just look at this broken code for a second. What? That doesn't make sense either. Right. Encoding the operand RSP. Plus value. Wait, no. I think it was correct before. It was correct before. We don't need this. In fact, I might just comment this out for now, completely. Now, the problem is these move instructions now don't work, because if we want to move into some offset, this is just going to move into RSP. It's going to override the stack pointer with this value 23, and then it's going to be all broken. So we do need something here. So if the operand is RSP, well, the problem is it's going to be different for a move versus other things like sub. So maybe these shouldn't be the same case. Okay, now encoding the operand destination. I was hoping we could just do it really simply like that, but we can't. So the problem is if I want to have a different output for sub and for move for if the destination is RSP, then I have to either pass in the operation here and then do like a little thing, or just have a separate case up here, I suppose, instead. So rather than encoding the operand for destination, I'm going to say, I don't know, encode move destination, which could be a different kind of thing. So now we know it's a move for sure. And we can do the same thing if it's a register, etc. But we just have a special case. We can't move into an immediate, so this just doesn't make sense. At least I don't think we can. I don't see how that would make any sense. So really we can only move into register or memory. Now that I think about it, the type for RSP should be memory. Maybe that's the problem that we're having here. So if we had a memory case here, then the syntax would be something like address plus offset, and the address would be some number, I guess. Or actually, I don't even know how to move into memory in x64. How to move into memory x64. All right, so you have to put the pointer into a register. That makes sense. So it would be register name plus offset. I assume you can do an offset. Yeah, the offset like plus 1, 2, 3, 4. Let's see. Yes, it's called displacement. It's standard practice for array elements, etc. Okay, that's good. So it'd be something like this. And then this would be register names operand dot register. All right, that makes sense. So maybe that's the problem, and I don't need this. And then it also means we don't need this separate case. Okay, so that should work. We just need to make sure that when we send in an RSP, it's not a register, it's a memory. Yeah, the register is RSP, I guess. So it's a memory operation and the address is stored in RSP. That makes sense. Right, and then there's an offset here, which is an immediate value with this size. Okay, cool. Is there anywhere that we need to take care of this? I don't know, I don't think so. I think that should just work, hopefully. Alright, let's just delete this code at the bottom. I think I already committed all this stuff to the repo, so should be fine. So this is a memory operand. Good, 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 good. Now, I probably forgot something. Let's see. Yeah. I forgot to type correctly. Missing argument. Okay. That is important. So this should be operand value. All right. Now, of course, these are all incorrect. This is an incorrect sub. Ah, we do have the same problem again. That's my bad. I mean, of course it's my bad. I'm the one writing the code. This is a sub, which is not a memory operation. This is a register operation. All right. So we've got sub RSP8. Now, when we make the move, where is that? Is it here? I guess it is here. So when we get the slot, reserve the slot. Oh, here it is. It's a move. Destination is... Oh, not that one. Here we go. Register RSP. But that's not correct. It's actually memory. Alright, how are we doing? How are we doing? Moving into the stack at the offset 48 to number 23. I think the offset should actually be... Should be 48? Yeah. Stack row is down though, so it should be minus 43, I think. Minus 48, rather. So, let's just change this. Then move into R10, that same value, then subtract some more space. Okay, that looks good. All right, well, time to check it in the debugger again. Okay. Now let me look at the registers. Okay, here we are. So, moving something into EDX. Wait, what are we moving into EDX and why? What? Oh, I think this is the... Wait. I don't see EDX anywhere here. It's RDX. Maybe it converted 123 down to a 32-bit. Okay. Very well, very well. And moving all these values into the registers, that's good. All right, here we go. Moment of truth. Sub from RSP. Move and access violation because, we're still, wait, what? That's not correct. There is no RBP here. Oh, I didn't type run. Whoops. Okay, so the code is still broken. All right, let's have a look at why it's broken. Ah, whoops. Okay. All right. So what is at this address? Let's see if we can we go to RSP here? Okay. So we're going to move into there the number 0x17. Oh, there it is. Is that valid space? I think not. I think it's supposed to be down here, right? Right, because the stack is all of this space. Okay. I mean, that worked, but I don't think that's right. Okay, now the stack is here. Ah. Okay. We've gone too far. Yeah. I'm stupid. So because we were using that base offset thing before, I was subtracting the offset, but really we don't need to do that. We can just move it into the where we just allocated on the stack, right? I think that's right. Let's see. Okay, well, it's still broken. Let's see how it's broken. Okay, so now we've got RSP is here. Gonna move this number into there. Great, thank you. Now we're gonna add more space. Gonna move a number into here. Okay, then why are we allocating 2 slots but then only moving 1 thing in? So allocating a full 16 bytes and then only using, I mean, technically we're using 1, but 8. Okay, anyway, move into RSP R11, return. Okay, completed the step. What's in RAX right now? Nothing. Okay. Okay. So we overrode the return address, I guess? Is that what just happened? Let's see. Okay, so the return address is this number ends in 09? Yeah, here. Here's a return address. We're going to come back and execute this after this call. Okay, it's still there. It's still there. Alright, so this is still here, but which register does it need to be in? Let's have a look. Oops. Windows x64. I know I've got the colon convention open here. Return, not return value. Where does Switz Mirts? Howdy doody. How you doing? Where does the return pointer need to go before ret? It's RAX. Denizo. Sorry, that name is very hard. Denizo. How come I typed that whole question and then it just didn't do anything? So you think it's RAX, okay. Right. The return pointer must be at RAX. Hang on a second. I thought the return argument, the return value was in RAX. Okay. State of the unused bits, etc., etc. Oh, I'm getting a headache. Great. Right. Okay. Well, let me walk through this again. So call. Now, I don't have the return address anywhere. I guess it's in... Oh, no, it's here in RAX. Okay. Right. Yes, I see. Move RCX 42, move RAX RCX. Oh, I see. Yes. So the problem is this reserve register procedure less than or equal to. I guess we got to just preserve RAX for the return address, or we could have pushed it onto the stack or something. Okay, still not correct, but we're not clobbering RAX, so we should know where to return to at least. Thanks for that, by the way. Okay. All right, here we are. Allocate space, put stuff in, allocate space, put stuff in. I'm gonna have to figure out why it's always 2 and we only needed 1, but that's a problem for another time. Because these values are getting copied back into registers, which is good. Oh, or into the R11, I guess, and then pushed onto the stack. Okay, now when I hit this return, went off the end again. Okay. Do I have to press F11 maybe? No. Okay, why don't I just not go into there? Okay, 1 second. What was that? Didn't mean to have a breakpoint here, but it said executing address 0x19. It's trying to execute what's in R11. Why don't I see that when I run through the program here? So I run through. And now we're at the end of the program. I'm missing something here. Ah. Hey, I didn't see this. Byte exceeds bounds, line 21. Number overflow. Let's have a look at that. Ah, because this is not keyword. I see. I see. All right. Now some stuff is making more sense, I think. If I manually change these, just for now. And then I call run, yeah. All right, so there's no errors, but we still did not get the result we wanted. All right, looks good. I mean, it all looks good, but should this be 3000 or should it be 3009? I don't know. So R10, R11 considered volatile and potentially changed by the callee on return. Maybe I shouldn't be using R11 here. Is that a potential problem? It did say it was trying to call. It was trying to call 0x19, right? Yeah. Or it's trying to run code at address 0x19, which is not correct. So maybe that's the problem as well. So rather than using R11, we'll use R12, I guess. But then it says non-volatile registers have to restore the original value after it's used. In case of RSP, it's automatic because of the stack. Okay. But this is telling me, what was it? RAX, R10, R11. Man. And then R9 is the parameter. Kind of annoying. I got this as return value. Is that just wrong? I'm not sure. But I gotta go. I gotta call it there. So we did, I think we did succeed, mostly. It's just a few bugs we got to sort out on the next stream. So I want to thank you guys for tuning in. And on the next one, we will figure out this calling convention stuff and finish it off. So cheers. Thank you very much.